Alright, adding and subtracting mixed numbers. It goes back to what we did for adding and subtracting. If you have not done that video, I would watch it first. But it's still the same thing. In order to add, you must be counting some common term, some common item. So apples, fingers, fifths, whole parts. So whenever we do adding and subtracting mixed numbers, you want to line them up whole part with whole part because these are like, and then fraction with fraction. And then that allows us to add them up. Doesn't matter the order. So 1 plus 3 is 4. And then if you have 2 fifths and 4 fifths, that's a total of 6 fifths. Alright, here's the issue. This right here, this is not a proper fraction. In order to have a mixed number, it needs to be whole part proper fraction. So that's 6 fifths we must convert. 6 fifths is the same as 1 and 1 fifth. This is what we did in dividing, right? You divide the fraction, it'll give you 1 and 1 fifth. Okay, now we can bring that 4 down, and we can add our whole parts. So 4 plus 1 is 5 and 1 fifth. That is our answer. The other option is you can go 5 times 4 is 20 plus 6, 26 fifths, and leave it as an improper, or convert the improper back to a mixed. It's your choice. But just make sure after you add these, you add whole part with whole part, fraction with fraction, and then the answer has to be whole part proper fraction. Alright, subtraction, exactly the same thing. 7 take away 3 is 4. Here's the thing, you don't want to do it that way first, because with subtraction you may have to borrow. So you want to go with the mixed number first, the fraction first. 2 take away 1 is 1 fifth. 7 take away 3 is 4. And you won't have to worry about converting these to a mixed number and then adding the whole parts. These are always going to work out this way, as long as the fractions start out as correct form. Alright, what if you just have a whole part? Well, you just add them together. 1 plus 3 is 4. And there you go. What if the denominators are not the same? Well, you make them the same. What is the common denominator for 3 and 15? 15 is correct. So that means we need to multiply the top one by 5. Which gives us 10. The bottom by 1. I know you don't have to. I like to do it. Which gives us 14 fifteenths. And that is the proper fraction. So we're done with that. And now 5 plus 3 is 8. And that is our 4 different types. You have a number that you have to convert into a new mixed number. You have subtracting. You have adding with whole part and mixed number, with just a whole number and a mixed number. Or you have adding fractions with uncommon denominators. Alright. Borrowing. This is a subtraction where when you try to subtract them, you can't. So you have 1/3 minus 2/3. You cannot take 2 from 1. So what we're going to have to do is borrow. And what we borrow from is the whole part, right there. And that gives us a 4. And then we're going to take and add that 1 to here. Now it's not 1 plus 1 is 2. This is not an entire whole. We're adding an entire whole. And one whole is made up of 3/3. So what we end up getting is this. 4 for our new whole part, and then 3 plus 1 is 4/3. The trick is this. Once you borrow, you just add the numerator and the denominator together. It's 3 plus 1, 4. It's 4/3. 4 take away 2. 4 take away 1. 3 is 1. And that is your answer. You could also take and convert them to mixed numbers. So 5 times 3 is 15 plus 1. 9 plus 2 is 11. And then subtract those. 16 take away 11 is 5/3, which is 1 2/3. They both give you the same answer. It's your choice. You can always convert a mixed number to an improper because they are the same type of number, just 2 different forms. Okay, what if your denominators are not common? Well, then you have to convert them into common denominators. So our common denominator here would be 8. So we multiply top and bottom by 2. And let's put a little line in here so we don't mix them up. So we end up with getting is 5 3/8 minus 3 6/8. And you want to keep rewriting these. You don't want to leave here and here. You might miss stuff. Okay, now they're common, but you cannot take 6 from 3. So that means we have to borrow. And the rule was you just take 8 plus 3 and you add them. So that gives us 4 and 11/8 minus 3 and 6/8. So it's 11 take away 6. It's 5/8. 4 take away 3. That's it. It's a nice little trick. You just add them together. 8 plus 3. Okay? Thank you. Alright, so here's the last one. This is special. And the reason it's special is you have negatives with it. And you want to think about the rules. That's what you want to look at. And you focus on the whole part. You have a 3 and a 1. Which one is bigger? 3 or 1? 3. The answer is going to be negative. If they're the same sign, that means we're going to add. So we're going to add, and we're going to get a negative. So now we can go 3 2/3 plus 1 4/5. And you don't have to worry about the signs. So you want to decide right off the bat, is the answer going to be positive or negative? Am I adding or subtracting? And you have to use your rules. Okay, common denominator. Common denominator here is going to be 15. So we need 15ths and 15ths. And that means the top one needs a 5, which will give us 10. The bottom one needs a 3, which will give us 12. We add them together to give us 22/15. And then 3 plus 1 is our wholes, which totals 4. This is not a proper fraction, so that means we have some more work to do. 22 divided by 15, that's 1. Remainder 7. So that means we have 1 and 7 remaining with our fraction, which was 15. Alright, so we have 4 plus the 1 and 7/15, which gives us 5 and 7/15. And that is our answer. And this is why it's special. Now, what's wrong with the answer? We forgot the negative. Exactly. We're supposed to add them, and then the answer would be negative. This includes everything. We have a common denominator to make. We've got positive and negative. We've got adding. We have converting to mixed numbers and then putting it back in. So that's why it's a special problem. I love that problem. Thank you.